And although there will be some things in the video you won't be able to see, I've got all kinds of technology to use today. We're going to get out the old laser pointer. Got too much going on here. So let's start with number 21. Here is the graph of number 21. And what is this graph? What graph is this? The what graph? No, it's not sine. It's just some curvy graph. That's what I'm talking about. Is this the f or f prime? That's what I mean. 21? Isn't that f? Okay. So, well, this is kind of a big deal, though, right? I mean, when we do these problems on the quiz, this is one of the things I was talking about yesterday, is if you get off, if you think that's the f prime graph and you start answering all the questions, you're going to miss every one in that section, right? So we've got to read it very carefully. That is the f graph on number 21. Now, the first thing it asks is, where is f prime negative? Now, I mentioned the other day that I'm not a big fan of memorizing just to be memorizing. There are some times, though, it comes in kind of handy that you might want to do it. I do want you to understand these connections. But you can, in trying to think about and understand them, sometimes you can confuse yourself more than is necessary. For example, what I mean by that is this. If you are, let's look at the very first question. It says, where is, let's do part B actually. It says, where is f prime decreasing? That was the same one that we struggled with on the homework yesterday. Where is f prime decreasing? So you're saying to yourself, okay, f prime is the slopes. F prime is the slopes. When are the slopes decreasing? Well, this is when we talked about this whole positive and getting less positive and negative and getting more negative kind of thing. To help us understand this, what does it mean for slopes to be decreasing? Well, slopes, if they're decreasing, could be like this. Okay, -3, excuse me, that's not negative. +3, +2, +1, 0. Or they could be like this, which would be -1, -2, -3. That's what it means for slopes to be decreasing. Now, what do you notice there? And the whole time, but I mean, what do you notice the graph is doing then? Well, local max, but that's not it. It's concave down. What we notice is that when the slopes are decreasing, the graph of f is concave down. So, we look over here at the chart, and in the chart, so what I'm saying is, yes, I think it's good for you to understand that when slopes are decreasing, it makes a picture that's concave down. But I don't think you need to think your way through this every single time. That's why we have the chart. What I want you to do is when you get to 21b and it says, where is f prime decreasing? I want you to come across the f prime line, see that when f prime is decreasing, f is concave down. And just do that. Do I want you to understand that the slopes decreasing create a concave down situation? Absolutely. But it doesn't mean every time you are asked a question about when f prime is decreasing, you have to go through that thought process. I think that's unnecessary, and it complicates the problem probably unnecessarily. So, back to this problem. So what I would want to do, let's do part A now. It says, where is f prime negative? So I look at my chart. F prime is negative when f is decreasing. So I come over to my f graph and I see that it's decreasing from here to here, which is where? I use my x values and I go -5 to -2. It is decreasing from -5 to -2. Now let's talk about a couple of things here. So we would write it like this, and then also it's decreasing from 2 to 5. So I would write it like that. Now we never, whenever we're doing these chart kind of problems, we never put a closed bracket. We'll always put an open bracket. And then the questions also come up about infinity. This problem, when it's boxed in like this, we'll just assume it starts at -5 and ends at 5, and that's all we know. It's not a huge deal. If this was a quiz and you put -infinity to -2 and you put 2 to infinity, I would probably still count it right. I'll probably remind you, I'll say, hey, this one's boxed in, just count it from -5 to 5, okay? But if it's not boxed in, if I just give you an equation like on 50 or 51, then we would probably talk about infinity in those situations. Okay, part B says, where is f prime decreasing? So we come to our chart, f prime is decreasing when f is concave down. Right there in the chart, there it is. Okay, so you come over to the f graph and it's concave down, I don't know, starting there, are we assuming? At 0. So it's concave down from here to there, from 0 to 5. Now, would it be good if you understood that f prime decreasing, the slopes are decreasing right here, they're positive and getting less positive, here they're negative and getting less negative? Sure. But if that just unnecessarily confuses you, don't mess with it. Just go with a chart and be able to answer those questions. Okay, 22 is just the reverse then of 21, so let's move on. So 23, where does f prime have its maximum value? So let's look at the chart. Okay, f prime. F prime could be positive, it could be negative. So when is that a max? The most positive. So we're going to come over here, and the most positive would be when f is increasing the most. See how I can even use that chart for that. So f prime is going to be a max when it's the most positive, which means when f is increasing the most. Well, that happens where? 0, right there, at the inflection point. That's when f prime, the slopes, will be the most positive. Then they want you to estimate that value, which means they want to know this slope right here. So if you go from this point, go over 1, it looks like, I don't know, 1.5, roughly, something like that. I would say about 1.5, maybe 1.8, almost 2 maybe. If you had 2, that's probably good enough. Okay, I want to see your tangent line. If you get a problem like that, I want to see your tangent line in your slope triangle and see if it matches up, and then you're probably pretty good. All right? Be sure and stop me if you got any questions here. 24, we're supposed to graph f prime, so let's make that red. So f prime. Okay, what am I looking at on this graph now? If I want to graph f prime. The slopes, because what I'm about to draw, the y values I'm about to draw are the slopes here. So what is this slope here? Well, it's negative. And it's pretty steep. I'd say it's at least -3 maybe. And that's about all the farther I can go down here. So I'm going to start right there at -3. Okay? And then what's happening to those slopes? They're still negative, but they're eventually going to be 0 right there. So this graph's coming up. Now, questions come up. Is it going to come up in a curve, or is it going to come up in a straight line? We don't really know. We don't really know. It depends at what rate these are getting less negative. And we don't know. I mean, we just can't tell just looking at the graph. So I don't care. Come up in a straight line, but typically we would curve. Okay? So it's coming up. All right? But otherwise, we really don't know. So it's coming up, and it's going to level off. Oh, wait, what graph am I graphing here? F prime, yes, I'm sorry. So what I'm doing is I'm plotting, yes. So what I'm getting here is negative, but getting less negative. So this has to come up, and right here, it's going to be 0. At negative. Oh, right. Thank you. All right, so negative, these are negative slopes, until right there, we're going to get a slope of 0. So this graph has to come up right there. Now the slopes are positive and getting more positive, and they're getting more positive until here. So this is going to come up and get more positive until here. Then what? Positive and get less positive until they're eventually back down to 0 here. So probably would curve more. I would probably curve it and then kind of come up. And then here it's got to be a max and come back down. The max would actually be right there. And then it comes back down. This is kind of messy. Okay, that's 0. Now my slopes are negative, and they're going to keep getting more negative. And so it's just going to go. So really, I'd say it's probably a parabola. My graph's not very good. It's probably okay? Now, some people might have said, what couldn't have been just a V, an upside down V? And yeah, you could have, but it actually is not a coincidence. If you have an x cubed kind of a graph for f, you get an x squared kind of a graph for f prime. That is not a coincidence. That actually does happen. So this is a parabola, okay, as it turns out. All right, let's go on. Now, the next graph we have is, what is this graph? This is f prime, or actually they call it g prime, okay? So let's talk about this. This is the more common of the situations actually that you run into. Okay, where is g increasing? So I'm just going to go a little quicker here. We're going to go right up the chart. So so we go to our chart here. This is g and g prime now. G is increasing when g prime is positive. Well, where's g prime positive? Which is to there. And over here 9 to 10. Now let's talk about this a little bit. Because what you guys said is actually a little bit off. I'm going to tell you, and was this one in the back? Look in the back. Look in the back while I'm writing this down. And tell me if I'm getting it right or not. No, 25. Okay, do you notice how they didn't separate out the 1? They did not say 0 to 1, 1 to 5.5, and then 9 to 10. Let me tell you why. I mean, it is just a little bit of a technicality. Okay, but it's an important technicality. And so the question is this. The question said, where is G increasing? So when we go to the chart, everybody look up here on the chart now. When G is increasing, G prime is positive. And vice versa. When G prime is positive, G is increasing. Now, it's not the whole story. Remember what the chart is. The chart is a nice way for us to organize a lot of kind of complicated information in a nice, simple way. But when you do that, you lose maybe some of the, some of the finer points. And that's what's happening right here. Okay, let's think about this. So, when G is increasing, which is what they wanted to know, G prime is positive. So let's go over to here. Everybody follow along with me. So right here, G prime is positive, which means G's going up, going up, going up, going up, until right here, what happens? Flat spot. Now G prime is positive again, so what's G doing? Going up, going up, going up. So now, the question is this. If you have a graph that's going up, flattens, and then goes up, is it increasing that whole time? The question is, or the answer is yes, it is. Even though it flattened at that one point, every point after the one before was a little higher than the one before, even where it flattened. So, if this question, which it is where is G increasing? It's increasing all the way until 5.5, and it's increasing from 9 to 10, including the 1. If this question would have been, where is G prime positive? You would have said from 0 to 1, from 1 to 5.5, and from 9 to 10. So it's a little bit of a technicality, because G prime is not positive at 1, but G is increasing. All right, so, like I said, a little bit of technicality, but it is kind of important to keep track. G decreasing is kind of the same thing, negative. So it would be from 5.5 to 9. All right, where does G have stationary points? Come over to the chart. G has stationary points when G prime is 0. So that is right at where? And it is important when you write your answer, you put x equals. So make sure you put x equals 1, 5.5, and 9. Okay, don't just write a 1 and a 5.5 and a 9, right? X equals. Where does G have local max points? Okay, so now we come back to the chart. Local max, and here I am on the G line. A local max is when G goes up and then comes down. G prime has to switch from positive to negative. So that's the first derivative test that we learned in that worksheet yesterday. So when G goes up and then down, G prime has to switch positive to negative. So where does that happen? 5.5, right there. 5.5. G prime goes from positive to negative. So there we have a local max. And so you need to write x equals 5.5 is the location of that local max. Okay? Local min would be when x equals 9, because at G prime goes negative to positive, which means G goes from decreasing to increasing. All right. What about this one back here? We already mentioned it at 1. Flat spot. Positive to positive means increasing, flattens, and then increases some more. Okay. Is G concave up at 3? The way you do this is you go to the chart. You say G concave up. Oh, G prime has to be going up. So you go over to 3, and sure enough, G prime is going up. So it is. And that's what you say. You say yes, because G prime is increasing. Is it concave up at 6? No, because G prime is decreasing. G prime decreasing means G would be concave down. All of that is right in the chart. All right. Then they tell us that this point is at 3.8, right here, and this point is at 7.4. What are those? But what do these facts say about the graph of G? Those are inflection points. So the only thing we haven't talked about on the chart right now is if we switch these columns. So right here, look what's happening on G prime. At this point, at this local max, G prime's going up, then going down. You come over the chart, G prime going up, then going down is a change in concavity of G. That's an inflection point. At 7.4, you got G prime going down, then G prime going up. So switching from down to up on G prime is switching from concave down to concave up on G, inflection points. All right. We're going to add more to that today. 33, we're supposed to sketch a graph of G. So let's get all this off of here, and let's do this. So this is G prime. Oops. All right, so this graph right here is G prime. Okay, we're going to graph G. All right, so what am I looking at here? These y values is what I'm looking at, right? So these are positive and getting less. So where do I start this graph? They gave me a point on the G graph. Yesterday we said when you do this, you often don't know where to start. But since they gave me a starting point, I'm going to do that. So I've got a y value 1. That means it's going to start with a slope of 1. But it's getting less positive. Right here, what's going to happen? Levels off. We've already talked about all these things, right? Because this is supposed to be a flat spot. We already had that earlier. Because now what? I got positive and getting more positive till there. So this graph is going up, 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 up until there. So these y values are positive but getting less positive. So this graph's going up, but it's going to flatten right there. We already said this was a local max. Remember that earlier. So we got a local max. So now we got negative values and getting more negative until 7.4. So it's going down, 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 getting more negative till there. What did we say that was? We said that was an inflection point. Now we got negative y values that are getting towards 0. So that means this is going down, 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 but it's leveling. So it levels right there. And then we got positive getting more positive, like so. Okay, so that'd be 0. So there you go. So your red graph should have some sort of shape like this, your G graph. Now, yours might have went up a little higher, yours might have come down a little lower, whatever, but it has the same basic shape. Okay? Same basic shape. That's what G should look like. All right? Then what do we do next? Tangent line. Okay? Let me skip to number 36 real quick. 36 said, could the G graph have been x times sine x? Well, what you want to do is just go to your calculator There I graphed x times sine x. What's wrong with this? Right in here, there should have been a flat spot right at the beginning, right? Remember, we said our graph was going up and leveling right away. It was concave down and leveled and then had a flat spot right away at 1. And we don't have that. So right off the bat, there's no way it could be that graph. Okay? All right. So all right. So now let's talk about the tangent line situation. They tell you that G, what do they tell you? G of 3 is 4. And then once you write the equation of the tangent line, what do you need to write a tangent line? Point and slope. Well, what they give you? The point. So that's easy. So they give you that. What do we need? G. Remember we said we're not going to use M anymore? Right? Isn't that what we need? We need G prime at 3, which Kelsey's got it. We're just going to look on the G prime graph. All we got to do is look at 3, look at the value. What is it? 2, and there it is. So there's number 34. It's that easy. Tangent line should be the easiest thing we do all year long, right? On 9, you look at the slope, and it is 0. So the slope is 0. The point was 9 and what? -1. Tangent line, you need a point, you need a slope. They usually give you the point, and they usually give you some information about getting the slope. All right? Just like that. Oh, no, I don't care. You can simplify that. Yeah, obviously, if you take this all times 0, it's going to be a horizontal tangent line. It's a lighter than sure. Okay? All right, let's move on. 46. I want to make just a couple of quick comments here. Because it seems like some of you had some difficulty here, but I don't think it was real difficult. Maybe you didn't know you could use your calculator. I think I said it though. And just graph it. On this quiz on Thursday, it's mostly going to be about graphs. Now we want to understand some other things. It's probably, I think at this point, I'm leaning towards doing all no calculator. So I won't give you an equation like this. Oh my goodness. We should be able to draw the graph of 3 minus x squared. We need to know at this point in time that that is an upside down parabola shifted up 3. Okay, we really need to know that. All right, and so we graph this. Now, what is that supposed to be in 46? That's f. Okay, so let's label it. So that is f, and let's go through the question. Okay, oops, color here. All right, so that is f. So here we go. How many roots does f prime have? Isn't this right? Yeah, look at my laser pointer. Isn't this a root of f prime? So what we're looking for is when f has a local maximum and a flat spot. So it's got 1. Where is it? X equals 0. Okay? X equals 0. Where is f prime positive? So we go to the chart. F prime is positive when f is increasing. This graph's increasing from negative infinity to 0. Negative infinity to 0. Where does f have a local minimum? Okay, f has a local minimum if this column goes from down to up. Doesn't it? Oh, I'm on the wrong one. You're right. Is f prime, I jumped ahead. I'm on another one. I'm sorry. Okay, 46b. Where is f prime positive? F prime is positive when f is, oh, we did that one right? Oh. Right. C, is f prime increasing at 2? Is f prime increasing? F prime increasing is when f is concave up. This graph is never concave up. So no. Sketch a graph of f prime. Okay, so here we go. So in red, we're going to sketch f prime. So what am I looking at here? This is f, right? So I'm looking at the y values or the slopes? I'm looking at the slopes. These slopes are positive beginning, less positive until finally they're 0. So I'm going to plot the slope. So I'm going to have a 0 right there. They're positive and getting less positive. They're coming down. Now, are they curving or aligned? It turns out they're aligned. We'll get to that in a second. Now we have negative and getting less, more negative, steeper. So it's just a line going like this. Again, it's not a mistake that an x squared f as a plain old X for an F prime. Okay, that it is a line. It actually is. Okay, but if you curved it on its way down there, no big deal. We haven't really talked about that at this point. Okay? All right, let's move on and go up to this one. Okay, let me get rid of this other one. All right, here is the graph on number, I'm going to skip to number 51. 50 is the same thing, but here's 51. Now the difference is this is F prime. Okay, this is F prime. So one last chance to practice. It's the same thing that we were doing in 21 through 36. So it says, well, first of all, about this graph, you need, for Thursday, not going to matter because we're going to do no calculator and I'm not going to give you any equations. But going forward, you need to be able to look at this and tell what that graph does. Matter of fact, that's why they gave it to you like this. Because if you FOIL that, it's an x squared, so it's got to be a parabola. So you need to look at something like that and think, oh, that's an x squared, so it's going to be a parabola. It's going to be a positive x squared, so it's going to open up. And where do you notice it crosses? See? Right? Because if you took this and set it equal to 0, they put it in factored form to help you. You set that equal to 0, and that tells you where it crosses the x-axis. If you know where a parabola crosses the x-axis, you know where the vertex is because it has to be halfway in between because of symmetry. So this is 6 across here, so halfway would be right there at -1. You know where the vertex is. So those are little things about these kind of graphs that you may be asked to do. Probably won't come up a lot, but it may. All right, so here we go. So we got part A. That's a good part of this. Where is F increasing? F's increasing when F prime is positive. So from -infinity to -4, and from 2 to infinity. Where does F have stationary points? That's when F prime is 0. That is x equals -4 and x equals 2. Where does F have a local minimum? That would be when F switches from, or excuse me, when F prime goes negative to positive, which happens at negative to positive right there. X equals 2. We would have a local minimum. Because that's when F would go from down to up, F prime goes negative to positive. That happens right there. And then finally, we're not quite finally, but when's F concave down? When F prime is going down. When F prime is decreasing. Well, that's from -infinity to -1. -infinity to -1. And the last one, what does a graph of F look like? So we'll get out the blue. Let's do a graph of F real quick. So what am I looking at here? Y values that are positive and getting less positive. I don't know where to start my graph, but since it's a positive slope, I'll start it down here. So it's going to be a positive slope, so it's going up, but it's going up less and less until here. So it's going to be up, 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 and then leveling right there. Then negative Y values getting more negative till there. So it's going to go down, 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 down until getting more negative till there. Then we got negative and getting more, less negative until we level off at a local min, which we already identified. That's a local min. And then we got positive Y values getting more positive, so the slopes are positive and going up. And again, it's not surprising that an x cubed F matched with an x squared F prime. Okay, it tends to have that connection. All right, that is pretty exhaustive look at the homework, and it was kind of important, I think, to do that this time. All right, get your notes out, and we are now going to add onto our chart some stuff about F double prime. Now, let me see, how do I want to do this? Okay, I better do it up here because we got people. Okay, so now, here's what this is going to look like. Obviously, you may already know that on our chart, this bottom row is going to be F double prime. Okay, so we got F prime, we got F double prime. Now, remember yesterday we made a list of connections. We made a list of connections between F and F prime. Keep going. What if I asked you to list all the connections from F prime to F double prime? It would be the same list. The same list. Because F double prime is simply the slopes of F prime. Just like F prime is the slopes of F. So there's no need to repeat any of those things. Right? But let's put them in our chart. Let's see what we can get in our chart kind of for free without having to learn anything new. And it would come right down here. So, all right, so if F increasing, let's look at this. If F increasing means F prime's positive, then over here, F prime increasing would mean F double prime is positive. And if F prime is decreasing, F double prime is negative. So those two we just get for free because it's the same connection between F and F prime or F prime and F double prime. Now what about these boxes back here? Nothing. Yeah, there isn't going to be anything. Because look, did F being 0 tell us anything about F prime? No. So F prime being 0 or positive or negative, that just tells you where the F prime graph is. That doesn't tell you anything about its slopes. You could have a positive F prime, meaning the F prime graph's above the x-axis, and not know anything about slope. So we didn't have 0 plus or minus up here, so we're not going to have anything here. So these are going to be blank. All right, so let's go back over to here. So we got those for free. Now what else could F double prime be? Increasing, decreasing, or what about 0? 0 is actually the one I want to put next. 0 is the one I want to put next. So if F double prime is 0 goes in this spot, what's going to go in the box above it? Stationary point. That's right. Now it's a stationary point of F prime, not of F. It's a stationary point of F prime, and that means you're going to have a local max or a local min or a flat spot on F prime. Now we actually have already talked about that today. I mean, let's go back to this picture right here. If you remember, this graph here was G prime, and we talked about a local max right here and a local min right here, and there's actually a local min right here too. And what were those on G? This is G prime. These were inflection points of G. Right? Now why was that? Well, that was because G prime was going up and G prime here was going down. Well, if we go back to the chart, when G prime goes up and then down, G switches concavity. So when we have a local max or a local min of F prime, we seem to get an inflection point. The problem is, what if we had a flat spot on G prime? Or let's use F prime. What if I had F prime here that did that? Well, F prime, what would F double prime be right there? No, 0, right? If this is an F prime picture right here, F double prime would be the slope of that, and that would be 0. On the left, you've got F prime going up, and on the right, you've got F prime going up. So that means you've got F double prime 0, but on the left, F prime is up. On the right, F prime is up. So is there a change in concavity? No. So we can't put inflection point in here just because F double prime is 0. Only if it's a local max or local min. So we're going to put in PIP, possible inflection point. So, and here's the thing. It's a possible inflection point. What has to happen for you to have an inflection point? switch concavity. You've got to have a switch in concavity. In this case, there's no switch in concavity because f prime is going up and keeps going up. All right, now let's talk about what we've learned so far. The real key to what we've learned so far when it comes to f double prime is in these two boxes right here. Now, Kelsey did mention a minute ago that f double prime could be increasing and could be decreasing, and that is true. And what would that mean if f double prime was increasing? F prime would be concave up and f double prime would be concave down. Unfortunately, that doesn't tell me anything about f. Just because f prime is concave up or concave down does not tell me what f's doing. So the real important new stuff is right in this section right here. Okay? So let me back up just a bit. So I had said a little bit ago, I had said, if we look at the connections from f to f prime, they're the same as from f prime to f double prime. So there's nothing new there. So the new thing for today is, what about from f to f double prime? What about from f to f double prime? Well, it's all right there in the chart. Okay? It's all right there now. Right here. If f double prime is positive, let's jot this down here. If f double prime is positive, what do you see about f? Concave up. It's kind of like we got a middleman there. We got f double prime is positive. Oh, but f double prime is just the slopes of f prime. So if f double prime is positive, that means f prime is increasing. Oh, but wait a minute. We learned yesterday that if f prime is increasing, f is concave up. So if we eliminate the middleman, what we've got is, if f double prime is positive, f's concave up. There you go. And if f double prime is negative, f is concave down. And if f double prime is 0, f is a possible inflection point. Now, what's it take to actually be an inflection point? Well, and I don't know if you want to put this in your chart or not, but to actually be an inflection point, what you have to have is you have to have a local max or a local min on f prime. Because that's what will give you the change in concavity. Right? If f prime is a local max or a local min, then you'll have f prime going up then down or down then up. That's what will get you to switch columns. And that's what gives you the change in concavity then. So there is the key part about f double prime. Now notice what f double prime mostly tells you about is concavity. If you want to talk about f and f double prime is mostly about concavity. F double prime positive, f's concave up. Negative, f's concave down. And if f double prime 0, means it might be switching. All right? So let's take a look. You can even jot this into your notes if you want to. But let's go back to this picture. But this time, I'm going to call this graph. I mean, you don't have to. Just try to focus in here and stay with me on this. I'm going to call this graph G double prime. So forget all the other problems we did with this graph. This is a new one. And we're just going to call this graph G double prime. Now, right? So right there, G double prime is 0. We just got done saying when G double prime is 0, we've got a possible inflection point. Okay. So, is this one an inflection point of G? Positive stays positive. Right? So therefore, what's G? What's G doing, right? Concave up, staying concave up. If G double prime is positive and stays positive, the graph stays concave up. There's no switch in concavity. Right here, right? Now, this is very much like our local max min situation from yesterday. If you've got a G prime graph that goes from positive to negative, we did that earlier today. Remember we said that was a local max? If this was a G prime graph going from positive to negative, there's that switch. That's his first derivative test right here. That's that local max or min. Now, since we're doing G double prime, we're talking about switching these columns. It's a change in concavity. So right here, we have an inflection point. What about here? That's also an inflection point. It doesn't matter which direction this one changes, because as long as it switches, we've got an inflection point. Okay, so we added that new twist in there because some of you are starting to get the hang of it, and we don't want to have that, right? As soon as you get the hang of it, we got to add something new to confuse you. All right, so here is that. Let's see. Let's turn in your books to page. There's a couple more things I want to talk about, and then I'll give you. We'll work, and then we're going to work some of the homework together, kind of starting out, and then I'll let you have some work done. So let's go to page 65. Okay? Page 65. Now they do talk a little bit about a couple of things here that I'll just quickly mention because they aren't anything too earth-shattering. You don't have to write this down or anything. They do talk about this idea we had talked earlier about position, velocity, and acceleration. Okay, well, position is like your F, velocity is like your F prime, and then acceleration is like the F double prime. Okay, so we always want to make sure we understand that connection. Okay, on page 65, there's a fact down at the bottom of the page. This is something that will come up at various times during the year, but since this section is about the second derivative, which is mostly about concavity, they do mention one other thing, that whenever we have a graph that's concave down, the tangent line will always be above the curve, and if you have a graph that's concave up, the tangent line will always be below the curve. Seems pretty obvious, but remember we talked about if you zoom in, right? And if we find the equation of the line, if we know points on the line, they're going to be a little smaller than the points on the curve. And here the points on the line will actually be a little more, the y values will be a little more than, because it's above the curve. So just this idea of above. Some books actually define concavity that way. Concave up is when the tangent line's below. Concave down is when the tangent line's above. So just a little bit of a fact, not a big deal, really. Okay, now turn to page 66. I got one more thing to talk about, and then we want to do some of the homework problems together. This is called the second derivative test. Now, I'm going to throw it out there. There are a couple of problems where this comes in handy, but most of the time we don't do much with this. But I want to throw it out there just so you understand. I think it's important to get the connection. Now, remember, the first derivative test was determining if you had a local max or a local min. And what we had to do is we had to look on both sides of our stationary points. We had to see if we were getting a change of switch. So is the graph going up then down? Well, if f prime is switching from positive to negative or negative to positive, then we have a local max or local min. That's the first derivative test. The second derivative test says this. If x sub 0 is a stationary point, which of course we know that means what? That's a stationary point of f, by the way. Well, local max, local min, or a flat spot. But what's it mean to be a stationary point? The derivative is 0. Okay, so we know that. So we know we have a stationary point. So we know we have, okay, a local max, local min, or a flat spot. So I'm just gonna write that. So x sub 0 is a local max, local min, or flat spot of f. So the second derivative test is how do we tell which of those it is? Well, here's how we do it. Okay, let me draw each of those. So let me draw a flat spot. Let me draw a local max. Let me draw a local min. Okay? Now in this case, what is F double prime? In this case, what is F double prime? 0. In this case, what is F double prime? F double prime, remember, is the concavity. What is the concavity here? It's not, no, it's not switching. Not, no, yeah, we do. Wait, this is F, by the way. This row right here is F. No, not, no, it's switching to positive, negative slope. Okay, now, okay, back to this now. Okay, back to our, where's my chart? Okay. F double prime, positive, negative, 0, depends on whether F is concave up, concave down, or maybe an inflection point. Okay, so let's go back to this. Isn't this concave down the whole time? So what's F double prime? Negative, right? And this is concave up the whole time, so what's F double prime? Positive, right? This is switching from positive to negative F prime, right? The slope, so positive then negative. But so what we're saying, oops, excuse me. So what we're saying is, the way we can tell, another way to tell if we have a max or a min, one way is to use the first derivative. So yeah, here you got positive slopes and they stay positive, so it's not a local max or local min. Here you got positive slopes and then they switch to negative slopes, so that's a local max. Here you got negative slopes and they switch to positive slopes, so that's a local min. So that's the first derivative test. The second derivative test says, look at the concavity. If you have a flat spot, there's no concavity. It's switching concavity. Second derivative is 0. If you have a local max, it's concave down. So the second derivative has got to be negative. And if you've got a local min, it's concave up. Second derivative has got to be positive. So they're saying that's another way we can tell if we have a local max, min, or flat spot. All right, you're going to see that in a problem just right now. So let's move to your homework. All right, so today's homework, 1.6, you're going to do, we're going to do some of this together out of here to start. And this is a little different than what's on the assignment sheet again, because I've kind of changed it up here. Okay, 1.6 is 37 through 45, which is another set of exercises kind of like 21 through 36 was today, right? Using the chart. So it's so important because that's a big part of what our next quiz is. All right, 1.7, we're going to do 4 through 8, which we're going to do together here in a second. 14 through 22, which is another one of those sections that ask you a bunch of questions about an F prime. F double prime probably is going to be involved here a little bit. 25 through 27, we're going to do number 26 kind of together here. 32, 33, 43, and 44. You're going to get in shape here. You're going to get in calculated shape. Conditioning week. Okay? Do it. We don't want to run out of gas here on number 43 and 44. Okay. Next problem. This is number 4, I believe. So let's turn to page whatever. 70, 68, 68. All right, J prime has a local max at x equals 2. What, if anything, does this tell us about J double prime or about J? So here we go. Here's a point 2. This is the J prime graph. What's that tell us about J double prime? J double prime is 0 at x equals 2, right? Because J double prime is the slope of J prime. So the slope has to be 0. Now, I will say that what if you had a local max that did this? Then we would say that J double prime is undefined. So I suppose the best answer might be it's 0 or undefined. Now, for our quiz on Thursday, I would accept probably either of those because our emphasis is more on curves, ones that are smooth and so forth. But I may give you a problem that has a sharp point. I want you to understand that a sharp point, the derivative is undefined. So if I give you a curve with a sharp point and say what's a derivative there, you need to say it's undefined. The slope's undefined. Be a little bit more of a trick, I think, to pull on you to do that, right? You do local max and you assume a nice curved one and you don't think of that other one. Probably not going to catch you on something.
Are there bonus points on Thursday?
I don't think so. We don't do a lot of bonus. I take them a few times. There are a few times, but I don't think there are. What about J? If J prime is a local max, what's that tell you about J?
Inflection point at x.
Inflection point at x equals 2. Not a possible, but an inflection point. Because if J prime is going up and then going down, look over at your chart, that means you're switching those two columns, so you're switching the concavity of J. So that's an inflection point at x equals 2. All right, let's go on to number 5. Here's number 5. Okay, read that. Is x equals -3 a local minimum? No? Why not?
Because f prime is 0, so it's an inflection point. Oh, no.
Now, the reason I like this problem is that we're so used to doing graphs, and the quiz on Thursday, most of it will be about reading off of the graph, but we do need to understand it to where we can look at them in some different ways too, okay? And this is one of those problems what makes you look at it a little different way. What's the first thing, what do you mean it could be a local minimum? So right up here, we know if f prime is 0, it's got to be one of these three. Local max, local min, or flat spot. Now, let's use that additional information. What's this first piece tell us? Anything? Tells us something. Well, we know the slope is 0, but it basically just tells us where that point is on the f graph, right? So if we go over to -3, we'll go down and right there. And we know the slope is 0, so we know we got something like that going on. That's what we know with those two things. Here's the key right here. Aha, go back to the chart. If f double prime is positive, well, it's actually what I just told you right back here. If f double prime is positive, it tells you it's concave up at that point. So therefore, since the slope is 0, it's either got to be a local max, local min, or a flat spot. Well, the only one of those that has concave up is a local min. So the answer to this is yes. This is the second derivative test. This is why I showed you the second derivative test, because the first derivative test doesn't work here. The first derivative test, you have to be able to know something on both sides of the stationary point. If there's a switch happening, we don't know that information here. So the second derivative test is what we tell. So since the second derivative is positive, means this is concave up. Since it's a stationary point, the only one of those three possibilities is local min, and it's concave up. Okay, Number 6 is a question just like that, so let's save that one for you. Number 7. Okay, here's this graph right here. (3x squared minus 2x minus 6). Now, that's f prime. Why does this imply that f has 2 stationary points? Okay, remember, a stationary point is when f prime is 0. So the question is, when is this 0? When does it cross the x-axis? Well, we need to know enough about this to know that this is a parabola that faces up. Now, it could do this, it could just barely touch, or it could do this. Do we know enough to know which one it is? Well, yeah, can't we plot a point or two? Put in a 0 for x, what do you get? It's got to be down below here, and since it goes up, we know that it's got to come up and cross twice. So sure enough, we do know that this f prime graph, we should know enough about this that this would cross twice. I think on Thursday's quiz, that's not asking too much to answer a question like that. You may not have to have a perfect graph in that parabola, but I think you need to be able to answer that. So yes, and I think a picture along with a little bit of an explanation would be the best answer here. Okay? That this graph would be a parabola facing up, it's going to cross twice, it will have 2 stationary points. Yeah.
So is that one for the explanation where you could put in the f of 0 and show it?
That it's -6. That's how you know that it's down below the x-axis. Right. Okay. And then the last one I wanted to do here is this number 8. It's not the last one. We're going to do one more together. But the last one in this section. F double prime is 6x minus 2. Well, this one to me is an easy one. This is just a line. So that goes down 2. It's going to have a slope of 6. So you're going to do this. And that's f double prime. And it says what? Explain why f would have 1 inflection point. Switches right here, right? From negative to positive. If we go back to our chart, right? F double prime switches from negative to positive. Then f switches concavity. And so therefore, that's exactly what we're saying. So right here, it goes from negative to positive. So therefore, that is an inflection point. And it never will cross again because it's a line. And that's why it only has 1 inflection point. All right. Everybody got the hats on? Are we logged in? Okay. What I want you to do, I'll get this ready. I want you to go to number 26. Okay? On your homework, turn the page. I think it's on page 70. Oops. Here it is right here. Okay? The directions are, one of these graphs is f, one is f prime, and one is f double prime. You have to tell which is which. Now, here's how we're going to do this. In this order, f, f prime, f double prime. I'm going to send you a little quick poll question on your calculator, and I want you to type in what you think it is. So if you think this is A, B, and C, just type A, B, C like that. If you think that one's A, that one's B, and that one's C, you just type in A, B, C in your calculator. Or CBA or BAC or whatever order you think F, F prime, F double prime. Think about it on your own a little bit. Ask each other if you need to. So you guys think about it, and I will get this ready and get it sent to you. Should pop up on your screen here eventually. Not everybody's logged in. Does everybody get the hats? It won't charge. Oh. So you don't think it's charged enough to do it? Probably. You can't even turn it on. Oh. Try.
I'll try plugging.
Yeah, try it in there. Try it in there and see. Okay. Well, just work on this anyway. Just write it down or something. Okay. Must just be maybe the Chromebook or something. Okay, it should be popping up and you should be able to type into it here pretty soon. Actually, up above where it says quick poll up at the top, if you pull that down, you can submit. But actually, I can see them without even submitting. I can see your answers here. Okay, I got 16 answers down here. We got quite a bit of disagreement. Interestingly enough. Uh-oh, some people are switching. Okay, I got answers from Tristan, Tiana, Zach, Allie, Brianna, Seth, Lacey, Courtney, Carly, Ryan, Mark, Mitchell, Kelsey, Jacob, Callie. I got people taking back their answers, changing their mind. All right, let's move on here. Now, let's talk about it. Anybody want to defend their answer? CBA. Oh, immediately, shots fired.
No, I just figured it out. I just figured that out.
CBA. What else? Who else has one? BAC. Anybody else? ACB.
Well, I know yours is wrong. So
That's mine. Oh, Mitchell has.
All right. Now, let's talk. Now, these are tricky, and I didn't give you a whole lot of time. I never had seen a problem like this all through high school, all through college, teaching for years. They went to a conference one year, and the instructor gave a problem like this, and it was somebody who used his textbook. Actually, it's where I got the idea of using his textbook. Anyway, you see all these calculus teachers sitting around arguing back and forth, and no, it can't be this, and it really makes you think. So I really liked it. Okay, Kelsey, what were you going to say? Yeah, go ahead.
Okay, if C is F, and you look at where it's concave down, which it starts at
Like right in here somewhere.
So when that's concave down, F double prime, which means
A.
needs to be negative. What is it? Okay, so I can't
Yeah, she's back, family. You know, well, here's something I noticed. First of all, first of all, when you get to one of these, if you find a graph, two graphs that have an F prime relationship, does that have to be F and F prime? It could be F prime and F double prime. Now what I'm noticing here is right here we got B and A are F prime and F double prime. Here we've got B and A are F and F prime. So I can tell, I mean, these two look like maybe that is what's going on. I'm not sure what's going on with this one. But what you would then do is then you'd look at the third graph and say, okay, that's F double prime, let's check. Here, let me show you how I would go about this one if this gives you any hint. First of all, I would zero in on the x-axis, no pun intended. See where the graph is zero, because nice things happen there. For example, if this, what I notice right off the bat is I notice that switching from positive to negative, which if that was F prime, what would that tell you about, and then I notice this right here, what should that be a local max right there? So to me, this looks like F prime because positive to negative does that. Then, so I notice, and then if I keep looking at my chart, when F prime is going down until here, then this graph should have an inflection point, right? A local minimum on F prime is a switch here, which gives me a concave up, concave down switch, so an inflection point. So I really feel good about these two having an F prime relationship. What you have to then look at is then, does that make sense that this is F double prime? And so if it is, what I notice and what we wrote, well, it's not up here on the board, but F double prime is all about being positive and negative, right? So if F double prime is here, it's below the x-axis the whole time, right? Which means F double prime is negative. What do you know if F double prime is always negative? F has to be concave down the whole time. And I think if you look at this, we just said that this switch is right here. Or think of it this way. If F double prime is negative, what do you know about F prime? If F double prime is negative, F prime has to always be going down. And here's our F prime, it comes back up. So I don't think it could be that one. So I think it's got to be this one. And let's talk about ACB. Why couldn't B or why couldn't C be the F prime? Well, if C is the F prime, it's negative the whole time. So that means we'd have to have an F graph that was going down the whole time, and none of these graphs go down the whole time. So that's why I believe it's CBA. So unless people have changed their answers, that would be Seth, Lacey, Courtney, Carly, and Ryan all had. No, wait. No, wait. Is that right? What did we say it was? BAC? CBA. Oh, wait a minute.
It was still us.
No, CBA. Yeah, Seth, Lacey, Courtney, Carly, and Ryan. Okay, CBA. All right. Now, part of your homework, okay, you got the rest of the time to work on your homework. Part of your homework is, what did I do with it? Where did I put your homework? Right there. Okay, so you got the rest of the time to do that. Now, 27 is another one just like that, so you can practice that again. Chances are pretty good you'll have one of those on the quiz where you have some graphs and you got to tell which one is which. All right? The rest of the time is yours to work. You may take the hats off now.
Probably not.
Right there.